We're going to take a look at a second day of reflection. So we had the packet the other day and we dealt with reflecting it using, say, tracing paper, or I think in here we just use notebook paper, and then you just kind of reflect it over. We also did it with the compass and straight edge, and then we also did it by coordinates. Well, this one would be really hard to do by coordinates, right? It would take us a long time to figure out where X and Y would have to go and exactly where the coordinates are. So what I would suggest, and I think the one that's probably most popular, is why don't we just go ahead and review how you would go ahead and use the tracing paper on that. So why don't you right now just take your notebook paper or your tracing paper, put it right over the top. Remember, when you do that, then you just kind of trace the triangle. When you use that, when you use the tracing paper, should you also trace the line? Yeah, the line itself is actually very important, right? And so when you trace it, it'll end up looking hopefully something like that when you get done, right? Give or take a little bit. Again, make sure you get the line in there. And then you flip your paper over, right? And then you line up the lines again. So for example, once you line up the lines, it should look, hold on. I'll be right with you. Should look something like that when you line up your lines and the points and everything, right? Kind of, you should be able to see through your paper and should look something like that, right? And then you just go ahead and trace ABC again, and it should come onto your paper. So you'd be sitting there like this. You would just kind of trace it in there like this. And then I know when I do it with just regular paper, some of the graphite actually comes out off onto my paper. And so then once I lift up my paper, I can just trace it again. Okay? Well, not what I wanted to do, but we'll just fix that quick. Undo. There we go. Remember, what that means is really this point, if I went straight to that line and then went out that same distance again, that's where the point should be. That's the reflection, because that should be the same, right? And so what point would that be right there that I just put in there? That is, we would probably call it A prime, right? And so then this point here probably didn't go very far at all for you, did it? So it's C and C prime at the same time. And again, if I went straight to that line and right out the other side, right about there's B prime. Okay? So it should seem very symmetric. Okay? So this mapping, if we wanted to, said it took triangle ABC. What's that symbol we used for like mapped or changed it? What do we write down? Because we're not going to write the word in there. Yeah. Yeah, it's an arrow. Mapped to triangle A prime, B prime, C prime. And remember, the order of the letters is important. Wherever A goes, you should put first, because that's what I put first in the pre-image. Okay, so pre-image is ABC. The actual image is A prime, B prime, C prime. So that's a nice little review of what we did before. Now we're going to talk about something a little bit more specific, and that's, this packet does not cover this. And that's what we could call line L in this case. In this case, we can call line L the line of symmetry. Okay? If something's symmetric, it means it's kind of the same on both sides. Okay? So in this last one, would you agree if I put those two together, that is actually the line of symmetry? Okay, that's where I could fold it up and these would match up perfectly if I put the two together. Right? And so the line of symmetry, if you want to put the line that the image is reflected over. So line L in example 1. Okay, do you have that in there already? Or? Oh, you do? Well, that was awfully nice of me. Point of symmetry. Normally I have you write it down because there are studies that actually show that you actually writing it down helps you remember it. Your brain stores it in an extra location when you do that. Okay? So the point of reflection for all points in a figure. Well, that's kind of an interesting one now, isn't it? The point of reflection. Well, what does that mean? Normally what I think about for this one, and the way I look at it, is one of the letters that we have, and that's the letter Z. I would say has what's called point symmetry. Okay? And normally the point symmetry is going to be the center point. Normally the way that I look at something like that, is if I took that z and I started spinning it about that point. So let's say I took a tack or a hammer and put it right into the smartboard there on that black dot and started spinning the z. Okay, that wouldn't be a very good idea, right? Good thing I can just spin it without that. Would I get the exact same thing I started with in the exact same spot before I went all the way around? And with this, how about now? Is that the exact same thing that I started with? How about there? No. There? No. Really, if I drew my z properly, that would be the exact same thing I started with, correct? And then I only went halfway around. So that would have point symmetry. Okay, but what really you could do is say if I start here, I go straight to that point and I reflect out the other side, do I get another point? And I do, don't I? That's what point symmetry is. What if I start here and go out that way and shoot out that way? Do I get another point? I do. Is there any that I can go on this z that it wouldn't give me another one out the other way? What about right here? Does that still work? Yeah, you go right to the point and out the other side. Oh, there it is. Oh, look at that. Can you think of other letters that might have point symmetry? What are some other ones that we have that might? Yeah. And right, yeah, we probably saw that part way through, right? But that's all right. It's fine. X, very good. A lot of people forget about that one for some reason, the X. Right? Because if I do the center point again and spin it, that would work, right? Any other one? And normally it's the capital ones, right? Oh, well, if you make the O kind of, well, no, O would work, wouldn't it? Well, maybe not that one, but a normal O would, right? Okay. Anything else? Lowercase l, that'd be true, right? If you make it like that, right? Lowercase l. S, there you go. That's one a lot of people forget about too. Ooh, that's actually pretty good. Look at that O and then look at that S. That's just ridiculous. All right. What else? And why are they getting bigger as I go across? I'm not really sure. What else we got? I. Obviously not the lowercase, right? But that should lead you to another one. No, not T. The I should lead you to a different one. H, somebody said it, right? If you just turn the I, you pretty much get an H, right? I think we've kind of gotten them all, haven't we? The ones that have point symmetry? Yeah, that's not a word. Hopefully nobody walks in right now and be like, well, these people can't spell at all. Next. I think that's about it, right? As far as letters. Obviously lowercase, well, lowercase n wouldn't work, would it? No. Lowercase x would. Okay. I think we did pretty good. Yeah. So now that we kind of know what point symmetry is, let's kind of go and look at these next ones. And then I've got another one for you to think about that's kind of weird. All right. So let's determine and show all lines and points of symmetry for each figure. So does every figure have to have point symmetry? Well, look at all the letters you didn't tell me. Right? So there are a lot of letters that do not have point symmetry. A ton of them, right? Okay, and they might have line symmetry, but we're only talking about point right there. So how would you line and point? Do you believe this very first one here, A, has any lines of symmetry? Is there any line I could put in there that if I folded on that line, it would match up? Yes. Okay, could you describe some of those lines to me? Right in the center. Yeah, I need a little bit more than that. Okay, so that's a horizontal line. So a horizontal line, so something like that, you think? I could fold it up on there. And normally I do dash because otherwise there could be a lot of stuff that come in here, right? Is there anybody got another one? Yeah, vertical, yeah, right down the middle. Okay. Yeah, it all depends on if that's a square or not, right? It depends on if it's a square. If it's a square, we could do the diagonals, right? But I don't think that one's quite a square. That kind of looks more rectangular, especially up here. So decide on your paper. Is your paper, does it look like a square? On yours it does, doesn't it? So on yours, it probably, this might be getting distorted by the projector or something. But on yours, I think you would also have these, wouldn't you? Because I could fold it on that line. Now I know that's getting a little busy, so let me kind of erase some of those and show you just one of them. For example, if I were to fold on that line, on yours, I think it actually would work out, right? Okay. And same thing, if I took that one away and just fold it on that line, I think on yours you're good. Up here, it really doesn't look like it. Okay, so like that, and that, and that. Do you think there's any more for this one? So those are all the lines of symmetry. I believe they are. So do we believe there's point symmetry? Now, you should always look in the middle for point symmetry, because you have to spin it and actually get what you got before you go all the way around, what you started with. So we're kind of looking, do you think that has point symmetry? Well, let's check it out. All right, so what has to happen? You got to spin it, get the same thing that I started with before I go all the way around, right? Well, that's definitely not it. So it's probably good for point, right? So apparently it must be, right? But it really doesn't look like it up here, does it? So did I get the same thing before I went all the way around? I did, right? Now we're really just getting freaked out now. Whoa, whoa. All right. But did we get the same thing before we went all the way around? We did, right? So does it have point symmetry? Yeah, it would have point symmetry right there. Okay? Because I can spin it on that point. Again, pretend you kind of put a tack in it and you're spinning just that center point stayed, but everything else was spinning. Okay? So I would agree. How about B? Do you think that has line or point symmetry? You think it has point symmetry? Has line? Oh, I've heard both. Where's line? How could you describe where that should be, that line? Now, here's what some people say. That would really be called the angle bisector, correct? But some people say, oh, but that one side, that one ray looks longer than the other one. But they're rays, right? They go on forever. Okay, so don't be sitting here and be like, oh, this one's 5 centimeters long, and that one's only 4, so if I fold, it's not going to match up. All right, no, they go on forever. All right, so keep that in mind. That, just see where would that be, and you could just say, kind of angle bisector would be a good one there. I really don't think that one has point symmetry. If I went to a point kind of, and what would the middle of that be exactly? At the tip, you think, like right here? But then as I spin it, you see how it would come out this way? And it wouldn't be in the same spot it started? Okay? If I use that as the center point, this whole angle would start spinning out this way. So the angle would kind of look like that, right? And then as I kept spinning, it would go that way. And I really wouldn't get the same thing until I went all the way around, correct? Okay. And plus, one thing you could do, let's say you don't get the spinning analogy, and that's fine if you don't. Well, let's put the point there. The rule is if I start at any point and go out that way and come out the other side, I better get the other point. And that does not happen, correct? I don't get that other point out on the other side, and I can pick any of them. What if I started there, go right to the line, go out the other? The point's not there. Okay, so that one does not have point, it only has the line that you show. Very good. How about the smiley face? Line? How could you describe the line to somebody? Yeah, that's the easiest way to do it, right between the lines, right? Right between the eyes. If I folded, do you think that should work? Probably. How about horizontal this time? Why not? The eyes would line up with, the mouth. That's not going to work. Any diagonal ones like last time? No? What do you think about point? Well, let's find out. Okay, so it's got to be the same thing. Now watch, this is really going to mess you up because this is apparently not a circle. Because watch, it doesn't stay lined up. It's apparently an oval, so that kind of hurts us. Wait, it matches up there on the outside, but not on the inside. Look at the eyes got all flipped over the plate. And that doesn't work. And then look at that, it's not even close. It's an oval of some kind. So look, I had to go all the way around to get the same thing, right? So does that have point symmetry? No, it does not. Okay. Yeah, that one was kind of creepy. All right. How about D over there? Line or point? Line, where's the line? Right through the center. You got to be more descriptive than that. Right through the center doesn't cut it. Horizontal. Thank you. Give me some adjectives here. There you go. Well, actually, I missed it completely, but it's about there, right? Probably a little bit lower. And I would fold it over and it would hit itself. How about point symmetry on that one? Because you would, again, the center point's even kind of hard to figure out where would the center point be, right? And if we tried it, in fact, I tried this one earlier. That kind of looks cool if you actually do it. Line it up. Whoa, line it up. So you start spinning, and oh, darn it. That's where it kind of looks cool, I think. But it definitely doesn't match up, right? So no point symmetry. Okay. Okay. So any questions on either point symmetry or line symmetry? Okay. Now here's something of interest. There's something that I know you've probably seen many, many times, and you didn't realize it had point symmetry. And that's a lot of the playing cards that we use have point symmetry. Okay? In fact, all of the face cards have point symmetry. Now, I'm going to stop the recording right now because then for those of you that are listening to the recording, you should just go get some playing cards because that's what I'm going to take out right now and show the class to show them that they do. And then I do have an interesting question that somebody last hour actually figured out. So.